Question 3. In a survey done to all students in a certain school, 80% consider themselves as creative and 60% consider themselves to be good at math. If there are 1,500 students in the school, then the number of students who consider themselves to be both creative and good at math could be any number from... This is very interesting. Here it says that there are two characteristics in this group of people. We have people who consider themselves creative, consider themselves good at math, and so we can use this as our intersecting characteristics. Here we can use the C standing for creative, and this negation of that is those who don't consider themselves creative, those who consider themselves to be good at math, M for math, and who don't. It says that 80% consider themselves creative, so we write 80% here, all the people who consider themselves creative, so it follows here should be 20. And for people who consider themselves good at math, would be 60 of them, so here should be 40%. They're asking us to count what's the range of values for the number of students who consider themselves both creative and good at math. So this value here, X. We know we cannot establish the actual value of that intersection. It's impossible if we don't know any intersections. But we can establish a range of values, the minimum and the maximum value. Imagine that you have a problem where you're able to establish what the total of each characteristic is. So you will have the total of the rows, the total of the columns, and the great total. But here, there's no way you can find, just by knowing the totals, all of the intersection unless they give you at least one of them. If you are not given any intersection, then you cannot establish the real values of the intersections, but only ranges of values. You can establish what's the minimum value, what's the maximum value for each of the intersections. Let's say in this problem, we want to find the range for this intersection. So finding the max value and minimum value for those who have characteristic B but not A. Okay, how would we do this? Let's see here, people. It's very easy. First of all, pick the values that correspond to the total of each column and row where your intersection is. So for example, X is part of row B and part of column not A. So we know that this count, X, cannot exceed any of the totals. So its max value should be 20. The max value of the intersection X should be 20. So you can write here a little something. The max value of a box is simply the minimum of the column total and the row total. Let's now talk about how to find the minimum value of X. Well, it's not always 0. Remember that the intersection counts, they always represent positive integer values, or 0 in the worst case. How can we find the minimum value of X? Since, for example, the sum of square box Y and X is fixed, is 20. So it follows that this sum is a constant value. If you wanna minimize the value of X, that means that Y should reach its maximum value possible. In this case, what we need to do is find the max value of Y, and since that added with the minimum value of X should be 20, then it follows that the minimum value of X should be 20 minus the maximum value of Y. So, take a look, people. What is the maximum value of Y here? If you just follow the directions in the previous slide, you just pick the least value of its two totals, that is 10. So perform this subtraction, 20 minus 10, and you get also 10. So the minimum value of X equals 10 as well. You can do that also using the box C. Okay, so let's find the minimum and the maximum value. Start with the maximum. maximum of x, it's the minimum of its two totals. So 60 and 80, the minimum is 60. That's the maximum value of x. What's the minimum value of x? We could try here and find what is the max value of y. So, and then we can do this, right? Subtract 60 minus the max value of y. So what's the max value of y? We can see it clearly, 20. So 60 minus 20 equals 40. And so x is between 60 and 40%. But turn into an actual quantity would be necessary to multiply by one factor. What is the factor that can take us to the actual quantities? Here, since you just need to multiply 100 times 15 to get the 1500 total students, so just multiply here by 5. Okay, so you have 600 and 900. So the answer choice would be there, C.